Hello and welcome. I'm Christie Iacomini, VP of Engineering and partner here at Prime Movers Lab. Thank you for joining us. For those of you who are new to Prime Movers Lab, we are a hard tech venture firm investing in prime movers, the entrepreneurs that have the ability to positively impact billions of lives. We focus on breakthrough science companies in 6 broad industry areas. Those are agriculture, energy, infrastructure, human augmentation, manufacturing, and related to today's topic, transportation. Before we begin, we'll do a little bit of housekeeping. We are going to keep this to an hour. Liz and I, my co-host, we have several questions that are going to lead our discussion today. We absolutely would love to hear your questions as well. You may use either the Q&A function or the chat function to enter those questions. We'd also like to hear your comments. As some of you know, we do publish a blog to summarize our key takeaways, and we might include your comments. So we're really excited to introduce our panel. We're very grateful for their time and their knowledge that they're going to share with us and you. Before we do, we want to tell you a little bit about ourselves because we are pretty excited about this topic. I'll start. For those of you who don't know me, I am an aerospace engineer. I have a master's and PhD with focuses in orbital mechanics and thermal sciences. I started my career at NASA and was there for a wonderful 10 years. When I transitioned into commercial space myself, joined a small company called Paragon Space Development Corporation, did a lot of space technology development and even some flight hardware development, mostly for NASA programs. After over 10 years helping grow that company and writing a lot of government proposals, I transitioned to Blue Origin, where I had the privilege to work with that team and oversee some of the engineering efforts to human rate their new Shepherd system, that orbital system you've been seeing a lot in the news the last several months as they shuttle commercial tourists to the edge of space. Ever being an optimist about exploration of space and the commercialization of it, I then started to lead the Blue Moon lunar lander. So obviously aerospace is a passion and the commercialization of it is something we're excited about. So with that, I'm going to turn it over to Liz. She can tell you about all the great things she's been doing.
All right, thanks so much, Christy. And I apologize for everyone who has to hear my lost voice. Sound like I smoke a pack a day, but I don't. So really excited for this panel. So grateful for all of the panelists, and I had the pleasure to meet everyone at AIAA Ascend back in November, most of the folks, and really excited. This is an area that I'm interested in and track. I'll give you guys a 30-second background on me because I'm also an aerospace engineer by training, as evidenced by my really aggressive wall decal behind me. So I started out my career in liquid rocket turbo pump design, did that for 7 years, worked on supercritical CO2 combustors for clean energy. And after that, transitioned to Lawrence Livermore National Lab here in California, where I worked on hypersonics. So about a year ago, I joined Prime Movers Lab, where I'm systems engineer and partner, and I had the pleasure to broaden my scope. And one of the areas I'm most excited about is the space economy, and in particular, some of the emergent markets we're going to be talking about today. So I'm going to start introducing our awesome panelists, and I will start with the first person I met at AIAA Ascend, Noor.
Hi, Liz. Do you want me to do a quick?
Yeah, about yourself, please.
Okay. My name is Nora Ward. I'm the Commercial Innovation Manager at the ISS. My portfolio is mainly focused on biomanufacturing. I have a background in math and physics and did a little bit of space policy in DC before working as a consultant for a space firm and also in DC. And now I'm happily employed at CASIS, ISS National Lab.
Great, thank you so much. Going in that order of cool people that I met at AIAA Ascend, I think Lisa, I met you next after Noor by maybe 5 minutes.
Thank you so much, Liz. I'm Lisa May. I am the Chief Technologist for Commercial Civil Space for Lockheed Martin. And I've been with Lockheed Martin for 3 years. Before that, I worked for myself as a consultant, and I primarily worked with startups and technology entrepreneurs, as well as consulting to what I consider some really great startups like new space agencies. So I worked on the UAE Mars mission as well, HOPE. Before that, I had 14 years at NASA, 12 at headquarters and 2 managing the Mars exploration program. My background is I have a master's in mechanical engineering, and my bachelor's actually is in speech communication. And before I went into engineering, I worked in radio news.
That's awesome. Thank you very much. And then Anjali.
Hi, thank you, Liz. My name is Anjali Gupta, and I am in a business development role here at Axiom, where my focus is building a bioeconomy in low Earth orbit. I have a background in early stage pharmaceutical drug discovery. I worked in pharma at companies like Pfizer and Roche. And then I moved into biotech marketing for a while and then pivoted into digital health. And now I'm in space biology and at the intersection of biology and business development. And I have a master's in physiology and a PhD in molecular genetics. Looking forward to this conversation.
Me as well. Great, thank you. And then last but certainly not least, I discovered I can make friends with people on Twitter. So Sinéad, I'm really excited for you to join our panel. Thank you so much. You're one of 2 space economists that I'm aware of. So really excited to hear your thoughts on everything.
Yeah, Liz and Christie, thanks so much for having me. I also sound like I smoke 20 a day because I have COVID at the minute, so you're gonna have to excuse my voice. I'm jealous that I didn't go to whatever event you all met each other at, though. That sounds like a ton of fun. My background is, like a lot of people here, aerospace engineering, primarily human spaceflight mission design. And I transitioned actually a few years ago into policy and economics. I focused mostly on economics, and it's an amazing way to combine my first and my main love, which is the space industry, with what I do at Harvard Business School at the minute.
All right, great. Thank you guys so much. We'll kick it off with our first question here. Normally, Christie and I would trade off, but she's got a bit of a video lag on her end. So I'm going to try to drive the questions, and hopefully her internet will improve and she can add some in as well, but I'll kick it off for us. So our first question is, I tend to think about the space environment in terms of what it serves for as like natural resources. So the microgravity environment, access to hard vacuum, and also the, what we can do with cosmic rays. So that was one of the more interesting learnings I had reading, I want to say last November, The Economist had a really interesting article on using cosmic rays to do favorable seed mutations for crops. So, there's all these sort of in different cases out there and things that we can do with the natural resources of the space environment. And I'm curious what each of you are seeing. And since you work for ISS National Lab, Nora, I was hoping you could kick us off.
Yeah, sure. So as you guys know, we leverage the microgravity environment quite a bit. There are a few different areas that we focus on, and we've seen some like great progress from even the commercial side more recently. One cool thing that comes to mind is we have a company called Lambda Vision that flew with us, and we try to leverage the environment to benefit humanity, being a national lab. And that was helping with macular degeneration, which is a phenomenon that occurs to a certain percentage of the population as we grow older. And so they were able to do a thin layer deposition, come up with these retinas to assist those with that disease. We also do tissue engineering and focus on regenerative medicine, things that would benefit humanity in the business case and medically.
Great, thank you. Anjali, I feel like you probably have some additional context on the commercial and business side, especially.
Yeah, absolutely. And Noor provided some really great examples. Thin layer deposition by Lambda Vision is such a great example. And 3D, so building on regenerative medicine, there's 3D bioprinting. As you take away that the gravity vector, you make the environment a little bit more conducive to depositing material in a 3D environment to make organoids or actually even tumor organoids that grow more physiologically relevant in space than they do on the ground. So incidentally, we had the AX-1 mission. That was, the crew was in orbit for the past 2 weeks. And one of the experiments was conducted by Dr. Kat Jameson. It's on her tumor organoids, and she was validating her protocol. We know that cancer is very plastic, very heterogeneous. So if we can actually take the tumors and grow them in space that are more physiologically relevant, then we can, move towards better drug discoveries. Another experiment, this is also really cool, is, forming more perfect solid lenses. So one of our private astronauts, Eitan Stebe, did this experiment for Technologist, Israel Institute this past week. And basically he tested a couple of different polymers, injected them into these solid frames, and was able to produce some really great perfect lenses. But one of the polymers was an unexpected result. So this will definitely lead to more research, but those are two examples. And I have many more, but I'll yield to the other panelists.
Great. Elisa or Sinéad, do you want to talk at all about sort of what Lockheed's doing, or what you're seeing from your interactions?
Well, like Anjali, we are also involved in commercial LEO scientific stations. So we are working with NanoRacks and developing Starlab. And it's something that I'm sure that Noor is also familiar with, is that space in that resource of microgravity, or the ability to use that resource, is really scarce. And so it's going to be really exciting to see how the entire community makes better and better use of access to different venues for microgravity and space science development in space. One of the other things I wanted to mention too is we're looking ahead to the lunar surface and the lunar surface economy. And there are resources on the moon that we all hear about, mining and excavation and creating propellant. And some of the other things are, we look at using the natural environment of the moon, for example, permanently shadowed places to keep things cold. And in fact, permanent sunlight to keep things warm as well. So, and then using the lunar regolith for a variety of purposes. So there is a lot of resources in space that we're working with.
Great.
Yeah, I guess on the venture capital side, what I'm seeing a lot more of, not so much specific use cases around, specific therapeutics or chemical or biological mechanisms, but more use cases around applying something learned from the space environment to an Earth existing industry, such as longevity. So the idea of increasing or slowing down the aging process on Earth, and this is a fairly new, very exciting industry is maybe too big of a term for what's going on there, but exciting area of focus for a lot of entrepreneurs at the minute on the West Coast, and a few of them are looking at space to try to better understand what actually happens to the aging process in space. How do we see that playing out? Because our body acts very differently, along the vector of time in space, and how do we try to isolate time from health outcomes in space, such that we can bring that learning back to Earth? So I thought that was a pretty interesting use case. And, I've seen a couple of different startups that are starting to think about the downstream of some of the science that Noor may have been talking about already. So that's pretty exciting. Whether or not we're at the stage where we can fund that yet is a different question, but certainly a lot of people are thinking about it.
Yeah, we identified disease modeling as being largely a part of the emerging market. We utilize microphysiological systems, and it's definitely going to be a growing market in the next 10 years.
And I just wanted to add, there's also chemistry, a lot of chemical syntheses that can, change in orbit. So looking at flow chemistry, which, we need to consider what are the technologies, what are the capabilities that are being built for space that will then unlock some of the, the secrets that we hope to leverage from this weightless environment. I feel that those technologies were still lagging behind, and I feel like there is an inflection point that's coming up. But it's really, it's like the really early stages of the internet, where you have this platform, but we don't really know quite how well to use it because we don't necessarily have the right tools. So at Axiom, we are working on, developing some new manufacturing processes or partnering with labs and companies to develop manufacturing processes in orbit, which will then, also apply to the moon and deep space missions as well.
Yeah.
Going,
Sorry.
Well, Sinead, both of you just sort of played into the thing that I was thinking about, which is that what we're looking for, the inflection point that we're looking forward to is when we are now doing things in space for space. And that a lot of the technologies we're talking about and a lot of the use of resources, either for the benefit of Earth, but also for the benefit of being Earth independent to a greater and greater extent, and the ability to use the environment of, say, the moon to understand differences that enable us to then use the environment of Mars. So, that idea that an asset in space can be an analog for another place in space, as opposed to focusing so much on the space to Earth and Earth to space chain. We're looking forward and out.
Oh, God.
Oh, I was just going to say that's a really great point in that, the technologies that we're developing on Earth, for example, synthetic biology, that field has been, slowly in the back, but it's really starting to take off. There are some really big companies like Ginkgo Bioworks and others who have made some really great strides. Now taking that technology, that Earth-founded, Earth-based synthetic biology, and applying it to, regolith on the moon or to other processes in orbit where you can take just some raw starting material, and rather than relying on a supply chain from Earth, you can make primers in orbit, for DNA synthesis or mRNA vaccines right on orbit. And that's the, the end-to-end future that, I'm envisioning and we're envisioning at Axiom. And I'm sure that's the future that we need to rely on to be able to, really start to live and work in space and become more independent as space explorers.
Yeah, I think that inflection point and a thing that would help us overcome the barrier and kind of fuel exponential growth would be automation using machine intelligence, AI, machine learning. That's really going to drive the next phase of innovation, in my opinion.
That was my question I was going to ask exactly, because one of the things that we're seeing are different approaches. Autonomous systems like BARDA, the exploration company, Outpost Space, versus human in the loop, Axiom with their commercial astronauts, and Titan Space Technology offering up commercial astronauts to do the work for researchers and companies. But what you just said, Noor, starts to answer my question, is in order to accelerate this booming market, it sounds like you're thinking maybe automation really is the first place to start.
Yeah, I think once we can remove human factor and get more of a closed system, and that way we can experiment with less sources of error. And I think that's the key to moving things forward.
And, at Lockheed, we're doing a lot of work with digital twins, and we're also working on the Lunar River with GM, which is going to be have level 5 autonomy. And the idea is that you either can operate untended or can operate with crew. I mean, there are a lot of things that humans can do. I spent most of my career on Mars, and there are a lot of things humans can do that a rover can't do. But it is having a flexible tool or a set of flexible tools where you can operate autonomously to support humans or operate autonomously to achieve tasks or accomplish tasks in space is important. And the other place where autonomy is going to be important is when we get to that future where we are manufacturing and assembling things in space, is the idea that the spacecraft would assemble themselves. So there's a huge level of autonomy there, as well as in the inspection and verification. Now we do verification and validation of everything pre-launch. And when you're building it in space, that whole paradigm changes, and the ability to do that without having to send humans to go do environmental tests in the environment, if you will. So I think that's another paradigm shift we're going to see in the application of autonomy.
Yeah, I really like what Lockheed did recently with open sourcing the modular design, right? So like, I think that trend of modularity in systems is going to continue.
And we're really focusing on sustainability and making things serviceable for now, and partnering with other companies that are working on servicing. Y'all know that, for example, we've invested in Orbit Fab and some other companies. So yeah, we're very much committed to making a sustainable community in space and being good citizens in that community.
I'd like to switch track now to go for a question on sort of demand elasticity and what we're seeing in the space economy. Christie, did you have another thing you wanted to do on this before I jumped? No? Okay. So I'm going to start kicking off this question for Sinéad then. So, we sort of see right now, I've been recently researching and trying to figure out for myself to answer this question of demand elasticity. There's a ton of small launch vehicles. We're actually seeing contraction in supply, right? With Soyuz sort of not being part of the international scene anymore. And then with the block buys that Amazon and Kuiper recently did, right? So on the top half of that, there's sort of, I listened to last Friday a talk on a space panel at Miami Tech Week, and they mentioned that Varda is going to be a big driver of that, right? Of being able to bring things up and down, right? So the down mass effect as well. But also talking to Dana Faber and Orbit Fab, right? They are third class mail, right? So they fill that demand elasticity as well. What else are you seeing? Like, how do you feel about that trend?
Yeah, demand elasticity is an interesting topic, because we often talk about how the lowering of prices, is massively increasing demand for launch services. And actually, that is somewhat true. It is mostly true, but when you look at what is driving that, it's interesting, right? So it is very true that SpaceX has drastically brought down the price of launch. There's really no way to argue that. What people conflate is that the lowering of price has drastically increased the desirability or the, I guess, the demand for launch services. When you actually remove the induced demand, so when you remove Starlink and you remove kind of, the launch provider's own assets that they're trying to launch, actually what you're seeing is not this massive increase that we kind of talk about in the industry, and that a lot of VCs and anybody kind of looking at the business of space will often cite. So I do think that I do think that demand will come for launch services, but I don't think we're quite there yet, at least not to the level that we have been repeating within the industry. The question then is, what do I think is going to fill that demand or to kind of meet the supply that's kind of in the pipeline? Yeah, it's an interesting question. I mean, I had a chat with some of the folks at Relativity recently, and they have seen, their business development team have seen a marked shift in the last year in, I guess, in small sat and other launch demand that just wasn't there before. So I think, when prices were drastically lowered, it takes time for an industry to catch up with that. And that's because you have to create a bunch of venture capitalists who have to understand how to invest in the industry. You have to find founders who understand the industry and can create a product or service in that industry. And so this takes, it can take up to a decade or more sometimes to create demand to reflect a changing in price. So I think we're getting to that inflection point soon, if not, already starting to get there now. And yeah, I think you're right. Like, I'm not sure what Varda in terms of their launch requirement looks like over the next 12 to 18 months, nor can I say the same for Orbit Fab, but I do think we're starting to get to the stage where there is a range of let's say, startups in the series B, C, D plus category that are going to start requiring somewhat sorry, my COVID brain is just not working right now. They'll need launch services somewhat frequently. Frequently is the word that I'm looking for.
Go, Lisa.
Sorry, Lisa. Yeah.
I was going to ask you a question. One of the things that we talked about a lot is lunar economy, right?
Mhm.
And we were talking a minute ago about Earth independence. And I haven't really seen it modeled much, is the impact of lower and lower cost access to space and how that affects the business case for in-space operations and manufacturing and resources. And so if it's becomes easier and cheaper to launch things, there's still an inflection point, but I'm wondering, I am literally just pondering what that looks like and what that modeling might look like.
Yeah, I think the question that you're wondering is how does an increase of launch supply or a lowering of cost impact, I guess, a supply of or the creation of an economy around that, right? So I actually wrote in the FT about this and got quite a bit of backlash against it. That when we talk about, or I guess when Elon Musk talks about, well, if all I have to do to make the Mars economy viable is to drastically reduce the price of launch. Yes and no, it's an indirect impact, right? Because if launch was free, it would still take numerous other dimensions of economic creation to put a sustainable system into somewhere like Mars. And so the question is a smaller version of that, I think, that you're referring to. Even if launch was free, what do we think that the in-space or the lunar economy would look like, and what services would be rendered there? And it kind of goes back to utility. What is the utility that we're ultimately trying to derive from the resources, or from having access to, whether it's a vantage point if you're Earth observation, or what is the utility there? And I think this idea of utility is an important one when we think about what is this, the total addressable market or the size of a lunar economy. Sometimes the utility is emergent, so we don't really know what that's going to be. Someone will think of something clever or interesting. For the lunar economy, I think right now it's just too early to tell.
We're gonna mine helium-3, right? And, diffusion of it.
I'm all in favor of fusion.
I think we all are big fans of it here as well. We have a no silicon private fusion investment, but also cheering on all the magnetic versions. Anything we can do for firm clean power, we're a fan of. Interestingly, talking about utility, we looked at an in-space solar company recently as well, and they would require quite a bit of up mass. So if launch was free, you might see one of those pop up. I was interested to see the engineering solution and the economics weren't quite as dire as I would have expected. But yeah, maybe free launch, Christie, did you want to address our next question?
Yeah, sure. Free launch sounds wonderful, but it depends on where and when. So we talk about SpaceX, their Starship being like redefining heavy lift to orbit, dropping plop 150 tons for you in a great location, but getting it to where you need it to go might be another service that's required. So then we're seeing a lot of direct to orbit launch services in those small to medium class, Stoke Rocket Labs, Spin Launch even. Their payloads are 30 kilograms up to maybe a ton and a half, right? Is there enough demand for those types of services to be complementary? And if not, what does it need to look like to maybe have that? Anybody? Sinead, maybe you have a comment, or we can start with you.
Yeah, I have a lot of thoughts on this, so I'm happy to get going. Not everyone's going to like them, so I caught up with a couple of aerospace investment bankers recently, and we spent nearly our whole time talking about Starship and like what the heck do you do with that? great from a let's move to Mars perspective, not so great from someone's going to bankroll this. And it goes back to your question, Christie, which is, what are we ultimately trying to achieve? So what is the utility? And what you're trying to do is get a specific mass to a specific location. When this is ultimately last mile delivery in space, which is a very difficult problem to solve on Earth with economic efficiency. And so when you're thinking about trying to solve it in space, do you really want to create this double solution of having, you know, having to break off your last mile delivery into two different service providers, and what does that look like? I don't think we're at the stage yet where we need to have multiple layers of transportation integration in, you know, in LEO or MEO yet, but possibly when you go further, you know, potentially to Lagrange points or beyond, that could be a possibility. But if we think about serving the current market, I think it's, you know, to be honest, I don't understand the economic case for Starship right now outside of government contracting in the future for large delivery. But yeah, the smaller rockets certainly make more sense. However, when you get into the economics of rockets, the bigger they are, the more, and that's just a fact. You got to go bigger to get the financial model right. So it's a really tough one. I think Rocket Lab are doing a really good job at trying to find that in between, and even moving upstream of launch to try to get some of the profitability into their business model.
Great, thank you. I'm going to jump to our next question because it'll go back to Nora and Anjali. So we have a lot of different options for up mass now, right? Big, small, medium, everything in between, reusable, expendable, etc. We're starting to see some new options for down mass. So how do you guys think about that in terms of the R&D and also eventually in space manufacturing for the different stations, right? So the paradigm we have today is we send down mass once every couple of months, right? Do we think that with Dream Chaser that will get better? Do we think that we're looking for cheaper, lower cost systems like what Inversion Space and Varda are doing? You know, what sort of, how do you guys think about down mass?
I think it could be a combination of all of the above, depending on the utility, right? I mean, right now there is a real need for down mass of biological payloads that are being held up on the station. These require power, much larger mass, volume, temperature control, multiple different levels of temperature, humidity, and, you know, all of the different factors that go into a biological payload. It also depends on cadence. So if we have, you know, some of the smaller payloads with smaller vehicles, there can be daily shipments back and forth versus some of the larger vehicles that are more involved. And then going back to some of the earlier questions, you know, we need to establish more efficiencies, right, in our payload development, payload launch, payload processing. And so that entire value chain needs to be disrupted. And I think that's where there's a lot of opportunity. And then going back to some of the comments that Sinéad was saying, and mentioning, you know, absolutely, but it's perhaps a disconnect between the types of payloads that are being focused on, because there's a huge unmet need on the biological side. You know, we need to develop operations and facilities to be able to carry these biological payloads from the ground to orbit, and then eventually, you know, have that self-sustaining operations that, you know, Lisa and I were mentioning earlier. So a lot to unpack there, but I think that more down mass capabilities definitely will move the biology side forward for sure.
Yeah, we have many different, we have like a variety and diversity of customers on the ISS, and I don't think that anyone is going to say no to alternatives or more areas and opportunities for up mass and down mass. I mean, that would be incredible. And with the LEO economy, who's going to I can't imagine anyone having a negative view towards that.
If it's all right with you, Christie, I kind of want to jump from this one to one a little bit further ahead. So, we're talking about up mass and down mass for, manufacturing and those types of things. But one of the other things that we see here as a trend is sort of the disposability of LEO, right? So shorter duration assets, things that are on orbit for 3 to 5 years, maybe, right? And then we just burn them up in the atmosphere, which is like an unintentional geoengineering experiment, which our chief futurist, Ramez Nam, loves. He's all about it. But some people are a little bit horrified by the geoengineering experiment that we're unintentionally doing. So one of my big questions is, what do you guys think the inflection point will be for in-space recycling, right? At what point, instead of burning up, will we have these autonomous systems? Ooh, Lisa, I saw you come off mute. I'm excited for this. That will work towards that. We saw companies, Lunar Industry, as looking at that. And there are others as well who are thinking about in-space recycling. Go, Lisa.
I obviously came off mute real quick. I feel like I'm on a game show. I pushed my button first, so yeah. But so I also have a lot of thoughts on this topic, and in particular, the idea that, and I'm going to talk about our augmentation port for a second. It's the one that we released the open source protocol for. The idea is that spacecraft would not be disposable, that they could be built with a short lifetime, but augmented either with capability, with new sensors, new propulsion, new comms, and have sort of a persistent way to upgrade things rather than throwing them away. Obviously, that's not the case, for example, with all the small sat comm networks. That's a little different paradigm. But for the things that really do not heavy lifting, that's not the right word. But in any case, the GPS, for example, which we said we were going to work with our customer to consider making that serviceable. And so the idea of disposable space will, I predict, go away. Probably not very soon, but it will eventually. And in terms of recycling, I love this idea. I do. There's a lot of space law and policy around that. For example, can I just go grab your satellite and like reuse parts of it? Probably not. So there's a lot around that. And then also, we don't see a lot of electronics recycling here on Earth. So there's some technical challenges to figure out even what would be, where an economic advantage would be to recycling spacecraft.
I am gonna, oh, sorry.
Oh, go ahead.
Anjali, no, go for it.
No, I was going to add to that. When we think about space stations, especially commercial space stations, you can imagine them to be this beehive of activity, right? Right now, the focus is on research and manufacturing, but also when you think about refueling or recycling or taking old satellites and refurbishing them, that can all be done in space. And that's also a paradigm shift in how we think about the utility of space stations as we go forward.
When we have that conversation about persistent platforms, I'm always the first to chime in and say space station is a persistent platform. Mm-hmm. And it's the existence proof. Admittedly, it takes humans to make it that way, but it's absolutely existence proof of the utility of that.
So Lisa said that she's thought about this a lot. I have not, but I'm going to push back against what Lisa's just said. Well, so, kind of. So I think there's probably two different, I don't know, let's call them like space economies in this specific context. One where we have these more persistent types of technologies. And that is probably the economy that's growing much slower. So when Liz says, how do we get to the stage where what has to happen that we start recycling? We don't get there in my mind, because what we ultimately want with the space economy is for it to grow fast. If it's growing fast, it means that ultimately things are getting cheaper, right? And the cheaper things get, the more disposable they become. We only start, and we can look at Earth is an analog for this. We only start recycling when it's too expensive, and when it becomes more economical to keep it rather than to get rid of it. But how we're trying to position the space economy is in the opposite direction, that we're trying to get things to be cheaper, and we're trying to push, more components that we can rapidly basically replace. So yeah, I guess having given it thought just now, maybe part of it is this more persistent technology that's much more expensive, that maybe venture capital isn't going to interact that closely with. In general, I know Axiom is obviously different, and there's a couple of those larger projects that venture capital is involved with. And then there are smaller technologies that will last for 2-3 years, and the business model relies on them disappearing so they can be rebuilt.
But don't you think that humanity is just, there's been a shift in humanity's philosophy as a collective shift? I mean, when we start thinking about circular economies, we start thinking about sustainability. I mean, we are seeing, the fabric of humankind change towards this, social responsibility. How does that factor into your beliefs? I mean,
so these are my economic beliefs, not what I think that this is how I believe the economy is going to work, not how I think it should work. So I'm just going to preface what I'm about to say because it's horrendous with that. But let's not talk about space. Let's talk about any other industry on Earth where we really, really need investors and CEOs to act differently. And the financial and economics incentive to do that just doesn't exist. So, when you ask an investment banker or a hedge fund, should we recycle this? And they look at their profit loss margins, they're going to say no.
In established industries, we are still a very much nascent industry. So I don't think unless there's a strong business case for them to behave in a sustainable way, or there's something on the regulatory or policy side that's forcing them to behave in that manner, I doubt they're going to put their benefit humanity hat on.
So taking a little bit different tack and going back to our launch vehicle conversation, is that the same discussion applies here, in the sense that if we're looking at the lunar economy and we're looking at the ability to make things more easily, more cheaply, more accessible, whatever, elsewhere as opposed to on Earth and launching it, at what point do these other resources outweigh the launch cost or the launch availability? So it's all sort of a fabric of something that's sort of still in process, or we're sort of paving the runway as we're landing here in some cases. But I do see that a lot of these business cases won't close unless we have ways to do things without going back and forth. And maybe disposable counts in that landscape, but I'd prefer to think that we would be moving in a different direction.
I think maybe there's just market stratification, right? So for the things that are more like LEO based and sort of space for Earth, we'll probably see our partner Anton likes to call it the Kleenexification of LEO. So I'm going to try to make it a thing for Anton. Hopefully that phrase will pick up. Probably not. But I think in geo and beyond, you're absolutely right that modularity, reuse, and eventually recycling, and also just doing things in space with raw resources, it has to be part of the equation.
But I also wonder if there's a little bit of a different environment here for us in space, is that unlike Earth, a piece of trash isn't going to bring down a whole infrastructure. But in space, a piece of trash will. And so I wonder if there's a little bit more imperative for us to not only put on that hat that we were talking about, that, for humanity, but for business, for good business. Constellations, it's in their best interest to keep their own orbits clean. Thoughts there, could that be a bit of a different motivator for us that's worthy of people actually being more sustainable?
Yeah, I'm super cynical. I only believe that things change when it becomes too expensive for them not to. As we're seeing with the, I think we've already passed the stage, unfortunately, with the climate, where the cost that we're paying today is in trillions of dollars excess of what it would have cost us to do something yesterday. But yeah, I think that's true. And I think it'll change when something has happened after a leading actor, no one cares if it's not a leading actor, has to pay the price, or unfortunately, if it's not an economic price, if it's human price, involving any of the humans in space, then I think that will incur a policy or regulatory change.
Thank you guys. I see a question that I like in the Q&A that I'd like to throw out to the audience, if that's all right. Christie, this is unplanned, but I thought it was interesting. So talking about when there will be a need for environments that spin to create artificial gravity for humans in space. So I think, Leo and beyond, right? So I open it up to the floor.
I will throw something out that is topic adjacent on this to get us going. And I don't know if any of y'all know Cheryl Nickerson. She does a lot of research on, in one of her areas of research includes microbiome in space and how it affects you. There's a whole colony of critters living inside us that also respond to zero gravity or partial gravity differently. And that is a huge unknown field that we actually have no idea how it will affect our health when we go places. And I'm not going to say advocate one way or the other about artificial gravity on spacecraft, but I will say that we will likely find things that will optimize human persistence in space for a long time, and that we know that much about it.
Yes, that's for sure. I mean, it's, billions of years of evolution, and this is where we are. So what is to say that, as we move into 10, 20, 30, 50 years, how quickly do we adapt? And what is that effect of weightlessness in our own human evolution? It's a question, that remains to be seen. But there could be value for artificial gravity in a weightless environment. We just simply don't know. I mean, this is a unknown, and hence we need to do a lot more research.
So I'd like to continue a little bit of thread on additional technologies. Artificial gravity is one huge one, obviously. Compute in space, is that something that you think is an enabler for the space market?
Well, it's something that, particularly at NASA, we have had this conversation forever about federated versus distributed computing. Mm-hmm. And where do you centralize that effort, and how do you optimize what has to be communicated? And, with communications, that's mass on a spacecraft, that's power on a spacecraft, that's reduction in payload mass fraction on that vehicle. And so we are looking at, right now, we're actually fully commercially going to start a lunar network. And the idea is, between that and the mobility that we're going to put up there, is to reduce the barrier of entry. And the same thing is, if you have compute in space, you also reduce the barrier of entry, because you don't have to have as much data transmitted back in order to get the information of the product that you're trying to get. I, a long time ago, used to tell scientists that, or tell engineers at Goddard, that no one cares what your spacecraft is. You could send a passenger pigeon up as long as you got the data back.
And then linking this back to our evolution, we need to rethink that idea of compute and storage in space. So, there's been a lot of development with DNA storage, but right now the retrieval is still technologies that still need to be developed. It's not as efficient, but I would say that in the next 7 to 10 years, we're going to get there. And these are parallel paths that will eventually converge, so that those DNA storage technologies to be able to read, write, access very efficiently will become the norm, probably in the next 10 years. So that's something.
We're seeing different types of models for compute in space. Some of them are to develop the space computer. Others are saying, no, let me develop the enclosure that protects it thermally and from radiation, such that whatever the tech, whatever the DNA type storage, you know, and other supercompute can just plug in. So that makes me think that the latter is the better way to go in terms of developing the in-space compute architecture.
Mhm.
Well, and then another piece of that is power. Computing takes power. And so, you know, when you're talking about the lunar surface, I mean, it's one of NASA's priorities. It's one of our priorities. You need the utilities, you need the communications and the power, and maybe a pickup truck or two. But
let's go there. Let's
your
go
best friend's pickup truck. Let's go. But it's true. I mean, so I know, and it is a priority for NASA to promote and facilitate the development of that kind of power infrastructure, because that's enabling for things, for large scale computing in space, for example, or for large scale resource utilization as well. So it's something that just sort of, there's an infrastructure layer there.
Do we need government's involvement to start building out that kind of large infrastructure? I'm thinking lunar power, lunar comm, the lunar GPS.
So we are, you know, Lockheed Martin is fully funding a communications network called Parsec that will do both comms and PNT. It's going to start small with one node and then regularly add nodes, and that's at the moon.
And for our viewers, PNT position.
Oh yeah, it's talking about is it precision or pointing? Navigation and timing. The navigation and timing I've got, but it's enabling navigation in a place where there's no GPS. I could not imagine my life without GPS, and having an ability to in situ figure out where you are and where you're going is huge. And you can imagine that just, you know, well, I landed over here way far away from that hab, so I didn't crush it. Now I've got to get over there. And so being able to build up that capability is really important too.
I guess going back to your question, Christie, it's interesting because you asked, would we need the government's help to build any of this? I don't know how we would do it without the government. There's no commercial use case there, right? That I am fully aware of that could offset the cost of this. So whether the government pays for it through some sort of subsidy or as the customer first and last resort, I don't see that we're going to do this anytime soon without the government basically investing in this infrastructure.
Well, this is something Anjali is also familiar with, so I'll tee it up and then let you talk, Anjali, is the idea of the government as the first customer. So for example, Starlab, our LEO station, is going to be privately funded, but the fact that NASA did put out a call and did provide funding, that's added incentive, and also government investment attracts private investment. So it adds credibility and sort of a part of the due diligence in some way. Well, the government's already looked through their proposal and is funding it. And so there's a little bit of cushion there. And I'll stop talking and let Anjali and also the folks who do capital talk.
No, I have to agree with that. I mean, government seeds some of the most novel, innovative, early enterprises. We have lots of examples from our history. And in this case, NASA government will be our customer as we're attached to the International Space Station when our first module launches in 2024. So government is definitely an important player. And even now with private astronaut missions, we have partnerships with global governments to fly and establish a presence for international governments in space. So it's government is a partner. And now it's an evolving partner. It's in a different way, a different kind of a partner as we're exploring space.
Great. I'm looking at the questions from the audience. We only have a couple more minutes left. Liz, do you have a favorite you want to throw out there?
A lot of them touch on international cooperation, and I feel like that could be like a bit of a landmine for us to jump over. So I think we're gonna leave those out. So maybe I'll just, ooh, my voice is dying. Maybe I'll open it up to the floor.
Well, I see a question in there on space tourism and getting opinions on, and it's one we talked about previously as a group too, is what are the thoughts on space tourism? And, you know, one of the things is, I think it's fascinating, and I'm really eager to see how that business model actually plays out. But one of the things that's always struck me is what space tourism gives us is incentive for more reusable launch vehicles. And that it's going to be adjacent to that launch capability that we talked about is, you know, well, if we can reuse launch vehicles, then we can do space tourism, but also if we do space tourism, we get bigger and bigger reusable launch vehicles. So that's my 2 cents on that topic.
And we get more money and funding for other areas that we'd like to expand on, like manufacturing and life sciences.
And I mean, Axiom is redefining or redesigning space tourism, right? I mean, we just are coming out of our AX1 mission, and you know, we call it a purposeful, meaningful mission because we were able to rely on, you know, 4 extra pairs of hands and eyes to do some incredible research. So, you know, speaking to Noor's point, and then I believe that it's humanity's presence in space that's going to drive, you know, that future forward innovation and you know, more capabilities in space. So once we have more and more humans in space, that's what's going to eventually drive that economy overall.
Yeah, I probably agree with Anjali. So as space tourism is more commonly defined today as kind of, you know, Blue Origin or Virgin Galactic, that business model doesn't close for me. When I think about creating a more sustained presence in LEO beyond and having this kind of multi-purpose use, so it's not just an experience, but it's also feeding into different types of revenue streams and kind of feeding into a larger economic play. I think that's incredibly interesting. But as currently defined through Blue or Virgin, for me, it doesn't really make sense.
Joyrides, yeah.
So all I'm going to say, it's a controversial one.
That's all right. We like the hot takes here. I think we're at the top of the hour, and I want to say thank you, ladies, so much. This has been an amazing panel, just a ton of fun. And thank you for your time, and thank you, the audience, for listening. And thank you, Christie, for doing this webinar with me.
Yeah, it's awesome. Thanks, Liz, for hosting. And thank you to our panelists. Have a great rest of the week, and keep your eyes looking up.
Thank you for having us.
Thank you so
Thanks,
much.
guys.
Bye, y'all.
Bye.